All right, so a number of months back, we picked up a dedicated Time Crisis 3 for the arcade, and it came with the original factory monitors. These are the Sanwa 27Z21Cs, and this one works perfectly. This one is dead as a doornail. It does absolutely nothing. You turn it on, and it makes no noises, no anything, like you don't even have it plugged in. But this one works just fine. So I took this one off just so we can do some contrasts and compare readings. But if we look at this one that's dead and we zoom in, I did a cursory look over. They're both completely untouched. I disconnected this just for the ease of working on it. But if we zoom in here on this resolution, these are just 15 kilohertz standard res chassis only, or these models anyway. You can see there's a connector here for high impedance and low impedance. I don't know if you can see that. Let's zoom in a bit. This is the low impedance, or low resolution, I should say. Low resolution, high resolution for standard and medium res. So there's no it's just standard res only. But if we look at the connector for it, just from doing some initial inspection, you can see that this joint here is, where did my tweezers go? Where did my tweezers go? It's always something. Well, we'll just use this. I don't know where the heck they went. All right, anyway. So if we look right here, this is completely cracked all around here. This whole joint is just completely cracked. And if we do some measurements here with the meter, I've got the meter set to continuity. So if we go from here, it should go from here all the way through to here, and we have continuity. But if we touch the pin, nothing. The pin has no continuity. Now if I push real hard on it, let's try it. Nope. My hands are dirty from handling the monitor. There you go. Push on it. Push on it. So I don't know what that being out of circuit would cause, but it's definitely a problem. So let's reflow that. And while we're at it, we'll hit the rest of them here. Now, I've never worked on one of these ever, and I have never featured one on the channel, and I have no idea anything about it. There's not much documentation out there for this at all that I could find. But now if we go from here to here, there we go, here to here. So I don't know what that being out of circuit would cause. That's the only thing that I spotted that was, obviously wrong, except for this. Oh man, this got burned up and went kablooey pretty good. So let's squirt a little alcohol on there and just clean all this up and take a look. Okay, so that all appears to simply be caused by this resistor that exploded. Now this resistor could have exploded because of the bad solder joint that we just fixed. I have no idea, but definitely a problem. Now if we measure this burned up resistor, we get it was reading 100K earlier. I think that trace might be broken as well that goes across there. That may be a problem as well. But if we read this here, see there we go, now it's going up. I think it's just bad connections, but 45K ohm. It's hovering right around 45, now it's 40, yeah, about 46K ohm. Now if we measure the other one that's not burned up, we get 1K, and it's stable. Now, okay, so that is, somebody has broken that trace, and okay, so that's supposed to be an open trace between there. So 1K ohm. Now, if we go back to our other one, and we measure it again, 45K, 43, 42. So we're going to have to remove this resistor. Because I'm betting that it is open. All right. Let's clean up this real quick. All right. So here is our resistor. And if we measure, what do we get? Yeah, obviously we need to take that other resistor off of the working one here and see what it reads out of circuit, because that's 38K. And let's flip this one over and just lift one leg of this off the circuit. And what do we get with this here? We get 1K. All right, so we need to replace that resistor with a 1K ohm resistor. And I don't know if we should really check anything else. There wasn't anything else that was... Okay, that's back together. There wasn't anything else I saw that needed immediate attention, but we're gonna have to find. Now, with that resistor close to this transistor, this Q801, I don't know what type of transistor this is. It's like a ceramic transistor. But if we test it, it reads fine. It's not shorted anyway. I mean, if we go negative center, positive to each leg, we get 0.5 and 0.5, so that transistor is not bad. Some of the flyback pins could use a reflow, but I don't see anything else with cracked joints or broken pads or really anything else that needs immediate attention except for this one joint. Now, I don't know if that would have caused anything, but we need to find ourselves a 1K ohm resistor. Now hang on, we may have some cracked joints here on this transistor. This guy right here, and that's awful close to that pin. That may be cracked as well. Let's reflow those and test that. The issue here is though that I don't, if this works after all this, I don't know if it's because of this joint that we reflowed right there, or if it's because of this that we reworked, or if it's because of replacing that resistor. I don't know. I don't really care, because if it works, I don't care. But it's interesting to note if it does work, we're not going to know which repair actually caused it to work. Man, that needs fixed, because nothing is sticking to that leg there. Where is that? That's right here. Let's see if we can get a little bit more out of that. Now that whole pad is gone, yep. Well, that's fine. Now we gotta take that out of there, because the leg is got so hot that the solder won't stick to it. So let's just take this transistor out real quick, clean up the legs, and put it back in. so that is loose. Now let's get this guy out of here. I wish I could find my stupid needle nose. Not sure where they went. Let's see if we can snag that out of there. Yeah, I mean, it just burned off. Look at the center leg is just gone. So I wonder if I can replace this. A1091. Let me look around for an A1091 and see if I can replace that. Nope, couldn't find one. So we're gonna have to see if we can clean all these off here. Okay, that's better. At least some solder will stick to that now. Let's make sure it's not shorted or open. I don't know if it's NPN or PNP, but let's just make sure that it's not shorted. So if we go center, this is going to be probably pretty difficult here. Set it on the flat side. We'll go center to each leg. Nothing there and nothing there. So let's go nothing there, nothing there. There we go, 0.6 and open to center leg. What does this one read? All right, so we've got our in circuit, negative in the middle. We got, that's not what we want. Okay, so positive in the middle on diode, negative to each outer leg. We got 0.605 to the right and 0.541 to the left. Now, because we're reading that in circuit, it's kind of misleading, so we're going to have to put this back in, and we got, what we say, positive in the middle, and then to the right was 0.6, and to the left was 0.5. So let's put this back in and see if we read the same thing here. Yeah, I'm just going to have to, can't find my, I just had them 2 seconds ago. Found them. All right, so this needs to go with the flat part towards the heat sink, so like this. We gotta bend the legs in slightly. Move this out. And come on. Oh, I don't think I have the holes opened up. Yeah, holes are opened up. I don't know what this thing's problem is. It's this stupid center pin. Try not to break this. If I break it, it's game over because I don't have a replacement. Although it may be bad, so it might be game over anyway. There we go. Push this down as far as I can. And hopefully there's enough. No, there's not even close to enough to solder onto. So I wonder if we could stick a component leg through there. Let's get a little bit of solder on here to hold it in place. Okay, there's that one. There's that one and that one. Yeah, that middle one has pretty much nothing there. Alright, we'll create a bridge across there. And yeah, there's nothing there. So let's see if we can grab a component leg. Got some laying around here. Here's one. Maybe put that through there. If we take this and kind of shove this in there a bit. There we go. And we'll bend it over and see if we can make this work. Nope. I need some flux here. I don't have liquid flux, so you'll have to grin and bear it here. Yeah, this is going to be quite the fiasco. We're going to have to go this way with it. There we go. I think that got it. All right. Now let's trim that off. Okay. Let's measure. So what did we have? We were looking for red in the middle, 0.6 to the right. 0.5. It says it cools down. It'll change. And then 0.5 to the left. Okay, I think it's good. And we want to make sure that I'm not going to be able to get to that. I wanted to verify continuity from here to here, but yeah. Okay, now we need our 100 ohm resistor, and I think we'll be ready to give it a try, but I want to reflow some of these on the flyback. Now there has to be a reason why that 1K ohm resistor burned up. I mean, obviously there's a reason. Now it's got to have something to do with this cracked solder joint down here. This one that we fixed. Now I don't know for sure, but I'm assuming that, you know, obviously it shouldn't be like that. So we'll give this one more look over here real quick. I want to turn my fan on to get rid of these fumes here. I'm going to give this one more quick look over. And yeah, I don't see anything immediate. Alright, so the fuses, of course, are good. I'm sure I heard some of you out there screaming, well, check the fuses. Not this guy. I think this guy over here was saying that. But just to show you here, the main AC input fuse is good. If we pop it out, good. It's always best to check them out of circuit. And now we have another fuse over here. If we pop this one out, it's good as well. So it's not a fuse issue. I think that we didn't have voltage getting to where it needed to from the resolution header right here. But I could be completely wrong. It could have been bad solder on that transistor. Could be the bad resistor where it was supposed to be 1K and we had 50K. It could be any number of things like that. So I think the only thing left now to do is to find a replacement resistor for the 1K, and let me go hunting for that, and I'll come right back. Alright, I found a donor resistor off of a Neotech 2515C. This was in location R205, and if we measure it, we get $1K. Perfect. Gosh dang it. There you go. Alright, so now we'll get this on here and then we'll put it on the tube and test it, and if it doesn't work or gives us absolutely no signs of life, we'll or if it burns this up again, we'll at least be able to proceed from that point. Crossing my fingers, of course, that this will work. Trying to do minor surgery here. Okay. And voila. All right. Now, if we measure this, we get 1K. There it is. So, all right, let's, we already checked this. We know there's no bridges here, but we'll go back to continuity, and nothing there, and we got continuity from here to here. All right, so I guess let's let's hook it back up to the tube and flip it on and see if we are back to life. All right, so this is a 27-inch monitor, so it doesn't quite fit on my bench all the way. It's kind of hanging off the edge here, but it also has this little proprietary Molex connector for your AC and your RGB and everything, so it's plugged in here kind of precariously. I had to remove the wires from, I don't even know, the connector that I normally use to plug in for the K7000s and stuff. Just extracted the pins and put them in there. So I'm not worried about or interested in the video signal right now, just power, because it was totally dead. I just want to see if we can get this to spring back to life here. So if it does turn on, then I'll cut away and hook up the RGB, which I have to hook up like this, with all the sockets removed from, what connector? I had a connector here. I just took the sockets out and they just plug right into here like the AC ones do. So, all right, let's just see if it even turns on. Here we go. 1, 2, 3. Dead. Oh, dang it. It does nothing. It does absolutely nothing. We are plugged in. I've got the connection right there. We have proper 115 here, and we have no activity in any way, shape, or form. Dang it. Well, obviously that has nothing to do with it. That broken solder joint, which is odd. You'd think it would have some type of effect on it, but wow. Okay, well, it could be caps. The caps are original, but I couldn't find a cap kit for these when I was doing some research. So maybe I can piece together a cap kit. I don't know, but further troubleshooting is required. Yeah, let's try again here just for the heck of it. We are plugged in. It goes around, and the AC input's actually right there. And we know the fuses are good. And we know I've got proper 115, or actually it's about 127 at the connector. Let's turn it on one more time. 1, 2, 3. Let's leave it on for a second here. It does nothing. What happens if I push a bit on it? Wiggle around. Nada. Okay, well, back to the drawing board. Let's take it back off and do some more troubleshooting. But now, if we keep going, knowing that RA10 reads 47K out of circuit, but in circuit will only reach 3, if we follow the trace off of R810, It's this little tiny resistor here. Let's get some light on it. It comes around this way. It goes down here to this, which is part of, I'm sorry, let me rephrase. This is the little tiny R810 right across here. You follow it down, it goes to this point right there, and it keeps going around here to Q805. This little NPN or PNP transistor, Q805. Now, if we go to ohms and we read across this tiny resistor here, R811, we get 28 ohms. Well, you can't see it, sorry. You zoom out. Right across that R811, we get 28 ohms. If we go across R811 on the working chassis, we get 6.9 k ohm. So, let's put it on continuity. And if we zoom in here, you'll see that R811 is in line here with these 2 points on Q805. Now if we go to Q805, we go to center with negative, we go to each leg, 1 ohm. That's 1 ohm and 28 ohms. So if we zoom back out, you can see center leg to upper leg, 1 ohm, dead short. Bottom leg, 28 ohms. So we have a bad Q805, which I'm sure is what took out I don't know if it's the base, I don't know if it's NPN or PNP, it's either base collector emitter. Let's just say base. The middle pin goes right to this leg of R810, which fried this resistor, and the other leg goes out here across R817. So yeah, our Q805 appears to be our culprit. So let's replace Q805. Hopefully I've got one. And I think I tossed that burned up R8, or that burned up resistor. I think I tossed it, unfortunately. I should have kept it so when we do our recap we can know, but if this fixes it, hopefully this fixes it. If it does, then we'll just have a bad Q805, a bad R817, and then whatever this resistor here was. So now what took this out, I don't know. I hope we don't replace it and have something else take it out, but let's grab it here. Where I'm losing all of my tools and I'm losing all of my patience. 805 is this one here. Okay, what is this? This is an A1091. Well, we already know I don't have one of those. Hopefully I can keep looking, but out of circuit, it's important to test components that fail in circuit. It's important to test them out of circuit in case it's not the component and it's something on the circuit. So let's flip this around to the flat side and center with the negative and 30 ohms and 1 ohm. So yep, shorted transistor. Let's go ahead and check the pads just to make sure those are right here and good. Now, does R810? Yeah, does R810 read 47 ohms with that transistor out? Ta-da! So, all right. So here's a prime example of just finding the bad component and going along the trace and seeing what else is on that trace. And we found the potential cause. Now we got to find an A1091. I'll see if I can keep digging. Maybe I'll find one. All right, so doing a little research here, I found that the A1091 is mostly used on the Cortec KT-1420A. And I just happen to have a parts board of the KT-1420A. I found one and installed it. So now with the replacement A1091 in there, I think I just said it. It's been a few minutes. Yeah, A1091. The base is the top pin, and the emitter and collector, I believe, are middle and bottom. It doesn't really matter. We're just checking to make sure that it's not shorted. So the base is on the top with the negative. And we go to the middle one, 0.6 voltage drop. Bottom one, 0.6 voltage drop. So we're good to go. Now if we go back to ohms and we read across R810, we should have somewhere around 47. 42 and climbing. Yeah, okay, so, all right, I think that's it. If this works, then we had a bad Q, what was it, 805? This resistor burned up, and we had a bad R817. So let's get it hooked up and test it and see if it turns on and what kind of result we get. All right, cross your fingers. Let's see. 1, 2, 3. Nothing. How can we find so many bad things and nothing that we do resolves the issue? We've got nothing. It's not an issue of not having power. We have power. Definitely on the right wires. It's hooked up. Nothing. Hopefully we didn't just take that transistor out again. I don't think so. I didn't hear anything happen or blow anything up, or it could be bad caps also. There's nowhere that I found that sells a cap kit for this, so maybe we will just try and hodgepodge a cap kit together and take note of the caps in the right locations and the call outs and all that stuff. I may just go ahead and do that on this one, but not, I may do a cap kit, but I can use the working one to document the cap locations and the cap ratings and stuff, because I want to try and get this one fixed. So we've got absolutely nothing. I did verify the wires are good from here to here, so here to the connection point, and it's hooked up. You can clearly see again that it's hooked up right there, and the wires run around the side here on the harness to here, and we're on the white and the white and black wire. Easy for me to say. We do have voltage hooked up, so let's try again. 1, 2, 3. Nothing. Well, I hope the flyback isn't bad, because who the hell knows if I can get one of those. But I guess what we'll do is, I guess the next step is to continue troubleshooting. Maybe there's a switch mode power supply chip on these like there is on the other chassis. Maybe I can decipher which one of those it is and isolate the power supply. This obviously is the power supply section here. Maybe there's some way I can do a light bulb test. I don't know. I'll have to keep trying here, see what I can figure out, and come back when I find something. Well, it's been about a week and a half since I just left you a few moments ago. I got busy with some stuff. I'm working on restoring a Nintendo Red Tent. I got most of that done. I'm still waiting on some various things to arrive, so that's been put back on hold. And it's time to come back to this. So I have not gone back and reviewed the footage, but I'm pretty sure I remember that when I last left you, we know it was completely, totally dead. And what we had found was Q805, this guy here, was shorted. We changed it, it made no difference. And then also we replaced this resistor that had blown up or burned up, whatever you want to call it. Replaced the burned up resistor, replaced the shorted Q805. I had to rework some of the solder joints on Q803 is what this one is, I think. I reflowed the flyback. I did a cap kit, a complete cap kit on the power supply section. It made no difference. And I think that's about where we were. I didn't notice anything really faulty or bad solder joints, so I didn't notice anything that was visually wrong. And then of course we found the Q805 shorted, the bad resistor, and Q803 all messed up. Got all that stuff done, and it made no difference, still totally dead. Now, knowing that this issue here, we had the resistor burned up in a dark explosion, and Q805 shorted, I started just checking everything in this area. Of course, when I did the cap kit, I wasn't able to physically reach down in here and put this cap in place, so I had to put it on the bottom for now. This little guy, I wouldn't worry about that little guy. So I started going through all this area here, testing all these transistors. There's a number of transistors here. There's, that one, these two. There's one there and one in there. I went through and tested all this stuff in that area, since that's the area that got damaged. And when I got to R804, R804 is right here, and it goes across this filter cap. So, using the other chassis as an example of what this is supposed to read out of circuit, I took the resistor out of circuit and it read 225 k ohm. On this chassis, it reads 4.4 meg ohm. I'm like, well, that's a problem. So I took the resistor out of circuit, it reads open, completely open. In circuit, it reads 4.4 mega ohm. And the good resistor and the good working chassis was 225K. So I don't know if that's our problem, but it is a problem. And just for show and tell here, we can show you what's going on. All right, so here is the resistor that I have removed from this chassis. And you can see my leads are good, 0.1. And if we test this resistor, we get, oh, no, that's the one I'm going to replace it with. Here we go. Here is the one I pulled out of the chassis, and it is completely open. Nothing. Wide open. Bad R804. So I pulled one from a donor chassis, and if we read it, it reads 225K. So I do not know if this is the problem, but it is definitely a problem. So far, we've had a shorted Q805 and a open R804. So let's get this installed and put it on a tube and see if it works. I'm gonna struggle to probably get this down in there, maybe not. Let's make sure the holes are lined up first, or the legs up for the holes, I should say, so it can drop right in, and it is. So let's see if we can drop this puppy in from the top side. Got it. That was a lot easier than I expected, and it lives right in there. So let's hold it in place, get a little solder on our iron. Okay. I'm going to turn my fan on here. Okay, now, with that replaced, being, if not the problem, at least part of the problem, let's see, it's still hot, so it's not going to read correctly, but let's make sure it's not 4.4 mega ohm. That's 2.6 mega ohm and falling. It's because we're reading across the filter cap. If I just touch across the filter cap here, will our reading change? You saw it read 225 out of circuit, so I'm not worried about what it reads in circuit, but yeah, see, I'm just going across the filter cap like that, discharging anything that was in there. Now it's reading, whoa, wait a minute, what's going on here? Let's get a good connection on here. 3.1 meg, 3.0, 2.9, and falling 2.8. So when I had the other resistor in here, it was 4.4 mega ohm and solid, was not moving. 4.4 solid. You can see here this is falling 2.6, 2.5, 2.4. We know out of circuit it read 225K, what it's supposed to. So yeah, with this in there, it was a solid 4.4, and we know this is bad. So after changing that out, let's go ahead. Somebody asked me in a previous video, how do I know when I can test components in circuit versus out of circuit? So the only time you should always test resistors out of circuit. However, only if they read out of tolerance. So basically, let's say this resistor is supposed to be 1K. I already know it's 1K from testing, but it's actually 0.988 or something. So let's say this resistor is supposed to be 1K. And if we read it in circuit, it reads, well, I'm sorry, 0.886. Let's say it's supposed to read, you know, if you look at the schematic, it's a 1K ohm resistor, and it reads 0.886. Now, I mean, that you think, okay, that's not enough for it to affect the system in a negative way, but what you want to do is take the resistor out of circuit and test it out of circuit. So the only time I ever actually remove a component from the circuit to test it out of circuit is if it doesn't test good in circuit. If you have a 1K ohm resistor on the schematic and you check it on the chassis and it reads 1K ohm in circuit on the chassis, it's fine. If it read, you know, 100 ohms, then you would take it out of circuit and test it out of circuit. The only time I take components out of the circuit is if it doesn't read correctly in circuit. Hope that makes sense. I had a couple of questions about that on a previous video, and I figured I might as well, since we're dealing with that subject right now, I'll go ahead and mention it. So now that we have that replaced, the bad R804, let's hook it up, power it up, and see if we have any kind of life at all now. Well, I'm going to cut in here and say that that did not work. In an effort to save time and not make a super long video, I put it on the tube and filmed it and tested it, turned it on, and it did nothing. Completely, totally dead still. I was super flustered at that point. But we know we had a faulty resistor at R804, so I started going further down the line here. So if we go to R804, that was open. See if I can get more light in here. R804 was open, and next down the line was R807, and that checked okay. And then we had R805, that checked okay. And then we had R817. R817, open. So resistor number 2, open. If we do some show and tell here, here is our R817, right there. And meter is good. If we test R817, open, nada. So if we grab an R817 from the donor chassis and test it, 1.5K. So resistor number 2 open. Let's get this one installed and see if it works after this. And I probably should go through and test everything else down the line, but I may just do that off camera. If I find anything wrong, I'll show it. If not, then we'll just install this on a tube and test it. And this resistor is right, it's not on. See, 805 is what was shorted. 803, Q805. Q803 is the one that was all messed up with the leads, and it's not connected to either one of those circuits. But it is, here's R804 that opened up. If we follow it, it's on the same ground plane. I think I already checked R808 was fine. That's a jumper that goes over here to C811. So there's nothing else really on this circuit that I see that could burn up. So let's get this thing soldered in, and then we will test it and see if it's any better or worse. I guess it couldn't get any worse. It doesn't even work. But let's get that guy in the circuit here. I think those are supposed to be tied together. Let's see if those are tied together. Yeah, okay, so we can just put a blob across here. There we go. Alright, so that's in, and we're not touching that. Those are supposed to be together. Let's look at our donor chassis here and verify. Yes, those two legs are supposed to be together. And let's test it in circuit now and see if it reads our 1.5K. 1.5K. You can't see that, but there we go. All right, well, let's see if anything happens now. All right, so we're all hooked up here, ready to go, and I gotta say, I really don't like this chassis because it's so cumbersome to put on and take off. Every time you want to try and test it, you got to put all this back together and put the chassis back on the plate, put the plate back on the frame. You got to hook up, there's a proprietary Molex cable that you put in here. You know, any standard game has a separate video signal connector and a separate input. This thing has one connector with everything in it, so I have to de-pin the connector and put the sockets on the right pins. And the wire wraps around and hooks deep inside of here on the chassis, and it's just a nightmare and very cumbersome to take on and off every time you try and have to do some repair. So we found those 3 bad components. Hopefully nothing else is bad because I couldn't find anything else bad. I checked some more stuff off camera, everything checked okay. So we're hoping it turns on and operates. If it does, we'll give it a video signal, make sure we get good raster. If that's all good, then we'll finish the cap kit and reflow it and call it done. But fingers crossed here that it actually just at least turns on and powers up here. So 1, 2, 3. Hey, yes! What do we get? No! No! Oh, dang it. Of course. Just sitting here so frustrated. Well, we're making progress. I guess we've got... So the chassis was dead because of a shorted Q805, open R804, and an open R817. So we have to keep going, and we're 3 components in. At least the power's up now. I don't know what took those out or why, but at least the power's up now. Now we gotta figure out the gosh darn collapse. Okay, gang, I have found the problem, or what is part of the problem, which I'll explain in a moment. But before I do, I mentioned a couple of times now a parts chassis, like the chassis that I pulled this extra R804 and R817 from, that were bad. I had posted online that I was fighting this thing, trying to get it to come alive, and somebody contacted me and said, hey, I have a spare one of those that have been sitting on a shelf forever that's a parts chassis, and you're more than welcome to it if you want it. I said, absolutely. And so they sent it to me, and it has arrived, and that's where I've been getting these parts from, and it's an exact same model. And you'll see the flyback is removed because I received this with the flyback separate. The flyback is right here. This was sent to me separately, and the pictures that they sent me showed it separate, and they told me that they weren't sure if the flyback actually worked, but they were certain that they would have thrown it away if it was bad, but they had no way to know if it actually worked. So they said this separately with the flyback wrapped up separately in the box from the main chassis. But this is the one that we stole the 2 resistors from that we used to get this thing up and running. And I also, in my efforts to try and get this working, I took this flyback in unknown condition, installed it. It did not fix the problem. If you go back, you may have noticed that the flyback has changed because this has some white zip ties and this one has the green ones. So during the troubleshooting process, I changed the flyback out with this spare one because I thought maybe the flyback was the problem. It didn't fix it, so I put the original back in. So if you notice that, that's why. There's no trickery or chicanery going on here, if you will. I just want to, I'm sure somebody probably would have noticed that, and I didn't want them saying, hey, you're doing some crazy things here and trying to trick us. No, I'm not doing anything like that. So this flyback, I don't know if it works, but at least we have a spare to find out if in the future, if this goes bad, I can put this in, see if it works, since we know the main board is no good. But I wanted to point that out. Because I needed to rob one more part from this thing, which I have already done and installed. And I found one more problem after checking it out. It doesn't involve powering it on, and I'll explain what's going on, but we have the vertical IC here. With having it in complete collapse, the first place I went to was the vertical IC, and that's this guy right here. Boom. Now, that's the one that I stole from the parts chassis. Now, here's the one that I just took out of this chassis. I would say that is no good. I lost my, here it is. Look, this thing just blew a giant hole out of itself. Kablooey. Nice big hole right there, and a whole chunk, this thing went kabam! Yeah, so it's a goner. Now, what could have possibly caused that? Well, I don't know. However, if we go to the chassis, we have a short across a couple of the pins. I'll put the meter in continuity mode just so you can hear, but if we go across pins 1 and 2, nothing. Pins 2 and 3, nothing. Pins 3 and 4, 6 ohms. I got a 6 ohm short across pins 3 and 4. Now I don't know if it's 3 and 4. Could be 1, 2, 3, 4, 5, 6, whatever, or 1, 2, 3. It could be come from this way or this way. I don't know. It doesn't matter. We're going to go from this way. So if we go 1 and 2, 2 and 3, 3 and 4, 6 ohms, 5 ohms. Let's go to ohms. 5.5 ohms short. So it's a good thing we didn't power it up after just simply replacing it and turn it on. But yeah, now we got to figure out where that short's coming from. And that's a jumper across to here, which goes, let's check C305. C305 is not shorted. So I don't think our short's across pin 3. I think it's across pin 4. Pin 4. I got so many tools here. So pin 4 comes down across this capacitor. It's in the mega ohm, and then it goes across this diode back to ground. Let's go here to these two aren't shorted. These two aren't shorted. These two aren't shorted. Those two are. Now, because I stole this off of a parts chassis, we need to verify that it's not actually the transistor that's shorted, because I'm looking for, here it is, because if it is, then we're not going to be able to use this, and we'll have to find another one somewhere, because this parts chassis was a parts chassis for a reason, and I need to isolate that pin. And let's make sure that it, let's touch the next pad on the trace. Okay, that's the trace. Now I'm going to touch the pin itself. Okay, the pin is still touching the trace. There we go. I gotta zap a little bit more off of there. How is that still? There we go. Okay. So now the pin is not touching, it's not part of the trace anymore. So now we need to see if we're still shorted to pin 3. And we are. So our vertical IC on this one is no good. So our short is the IC. So I guess I installed this for no reason. So I gotta see if I can find, I gotta find another one. Because it's likely we would still have a short, or collapse I should say, even after replacing this. So when you're stealing parts off a parts chassis, this is a good example of what you should do, because you always want to verify that the part you robbed, if it's coming from a parts chassis that has known issues, you always want to verify the part is actually bad. So, or I'm sorry, actually good. You don't want it to be actually bad. How about that? This thing has still got me all flustered. All right, that should come out now. Okay, well, I gotta see if I can find one of these. So let's see. This goes in this way. Flip it around. Is it these two? Yep, 6 ohms. So we got another bad one from our parts chassis is faulty. This one's not shorted, but it wouldn't be when it's blown itself out. So NTE. Let me see if I can find an equivalent, because I've got a bunch of these for a K7000, but I don't know if it's an equivalent. This is a 1378. And this is a 1733. I'm sorry, 1773. Plus it doesn't even mount properly. No, I'm sorry, I grabbed the wrong one. This is the one I meant. LA 7833. NTE 1773. And you can see they're the same thing. But I gotta see if it's equivalent or compatible. If it is, then we'll just throw one of these in there. Okay, let me find out if this is a compatible donor here. Alright, so it turns out the LA 7833 has all the exact same pinouts. The voltages are within the tolerable spec. Everything appears to be good for it to be a replacement for the NTE 1773. So, yeah, let's turn it on and see if it works. I forgot to turn out my light here. There we go. Alright, just so we can see better. Okay, on paper, it appears to be a valid replacement, but I haven't tested it yet, so let's find out. 1, 2, 3. Okay, it comes to life. Do we get full deflection? Yes. All right. So let's turn this off. Making progress. Okay. Let me get the camera on a tripod. Let's get a video signal hook up and see how well we can make this look and kind of go from there. Alright, so we have all of our connections here rather haphazardly installed. RGB, ground, and sync with our power. Nothing's touching, everything is separated. Let's turn on the TPG and let's set up the camera. Alright, well, let's see what we get here. 1, 2, 3. Oh, we got an H-hold problem, sounds like. Oh no. Something is screaming and it's not very happy. We did have an image though. Let's get rid of this thing here. Let's turn all of our RGB to center. Everything was maxed out. I didn't check the pots beforehand. Brightness all the way down. Screen pot all the way down. Okay, let's see what happens with that. Okay, I don't have the screeching sound anymore. Let's turn up the flyback. Let's go right there. Brightness. Oh, now the screeching sound is back. Vertical size, each hold, vertical position, vertical size, width. We need to adjust our pin cushion. Roughly there. Each position. Let's go to H size. Well, that's odd there. That's odd as well. There it went. Oh, wait a minute. Oh, I'm hitting the... Something's odd there with that. Huh. Well, we have a full picture. I'm not sure what that high-pitched noise is. Oh, it's the flyback. Well, I guess the answer is revealed. Can you use an LA7833 in place of the NTE, what, I forgot what it is already, 1773? Yes, you can. All right. Let's go through and check our RGB. That's kind of weird. That's weird there. I don't recall that being like that. That's not, what's going on there? It's weird. Huh, that's odd. I'm not sure what's going on with that. If I get RGB, this doesn't seem right. We may need to adjust our B plus because the flyback is screaming at me. But yeah, odd. Well, we got a full square image. Let's give it an actual real PCB signal. Let's hook up our MK1. Okay. Let's switch over our TPG connector. Okay, let's see what this yields. I think we just need to adjust some colors here. Brightness, right there. H position. Whoa, that's not right. Well, we got a full square image, but the colors are way off. Let's try and hit green's all the way up. No, that's blue. Blue's all the way up. Green, red. We're missing blue because my connections are bad. Hang on, let me play around with this. I'm missing blue because my connection I have a bad connection for the blue on my connection here. Hang on one second. Okay, I got the blue back. Bad connection, like I say. Hey, there we go. Now we're almost a bit too blue. Let's turn our green down a bit. Red down a bit. Let's put our other. So there's 3 adjustments on, look at how good that is. There's 3 adjustments on the main chassis and 3 adjustments on the remote board. So I'm going to put all of the color pots on the main chassis to center. There we go. Now let's fine tune with the ones on the remote board. And that looks pretty good right there. Let's adjust focus a bit. A little too red. Well, there you go, ladies and gents. What do you think of that? Sorry about the refresh rate there. Can I zoom in a bit? Nope. That refresh rate's a killer. Sorry about that. If you got sensitivity to flashing in, I'm sorry about that, but can I get it to go away? Oh wow, we're way too red. And I think we're too bright also. That's better. That's better there. Okay. Okay, we'll call that a success. I still got some more fine tuning to do, but I won't bore you with that. You're right there. Yeah, that looks pretty darn good. So, yeah, we had what? We had a bad R804, a bad R817, a bad Q805, and a bad vertical IC. I think that was it. It exploded vertical IC. So the Q805, the R804, and the R817 were causing no power, no high voltage energization, if you will. Was causing the monitor to not power on. There you go. And the vertical IC was exploded. So after replacing all those components, we're back to working. All right, this was a head scratcher. I'm going to go through and do the few remaining caps that I haven't changed out. I'm going to get those changed out. And then I'll do a full reflow, and we will have another successful repair. So thanks for watching. Hopefully you learned something. Like, share, and subscribe. I appreciate it. And I will see you on the next repair.